Hello, good morning, everyone. Can listen or not? Iru, can listen or not? Hello, morning, Zihui. Can listen here or not? Okay, Esther, morning. Okay, Katija, Iru, can. Okay, so I go to show my slide lah. Okay, everyone, morning. Okay. Okay, so from here today, we want to continue the lesson. There's a semiconductor also, but this one is a series 2 lah. We continue with the next one. What's a function for semiconductor? Okay, so today should be the 5.2 again. Semiconductor diodes, but this one is a series 2. Okay, we go through the another function for semiconductor. Before that, we learn about semiconductor function is let the current go to one direction. That means they block the current move in opposite direction. Okay, this one is the first semiconductor diode, the functions. Okay, now we need to introduce another function for semiconductor. Okay, good morning, Dandridge. Okay, then we go through the one of the diagram. Okay, a smartphone is being connected to an alternating current power supply at the home. Okay, everybody know our home, they get the power from the power station. So that one sure is an alternating current and also 240 volt, is it? But the smartphone can only be charged with the direct current. So what we need to do, so that means your charger, inside your charger, first one, they must have the transformer. Okay, they step down the voltage. Number two, they must something to help to convert alternating current become direct current. So from here, how does a semiconductor diodes that can convert an alternating current to direct current? So this one is a second function for semiconductor diodes. Okay, the first one is they just let the current flow in one direction. Second function for semiconductor diode, they can convert alternating current become direct current. Okay, let me go to the following. Okay, we can see the first one, rectification. Rectification is a one of the process. Okay, one of the process they want to convert the alternating current become direct current. So this one we call rectification. So that means semiconductor diode, they want to convert the alternating become direct. So they must through this process. Okay, rectifications. Okay, let's see the process. Okay, diode, we can say there's a rectifier. Okay, because there's an object to help to do the process. So they become the rectifier. So diode can be act as a rectifier because they can convert alternating current become direct current. Okay, so this one is a function of the diodes. They can convert from the AC become the DC. Through what? Through the process. What process? Rectifications. Okay, sorry, I got to change back. Okay, rectifications. Okay, so from here we go through. Wait a while. Okay, so from here we're going to see this part. This one is a symbol. Okay, symbol for the diode, is it? So anode is joined with the positive. This one is a cathode. You join with the negative. Okay, this one, that means the positives must go from the anode, go to cathode. So that means they just let the current flow in one direction. Okay, when this one semi diode you just apply to the circuit, then they will process the rectifications. Okay, so from here you can say the function is from the let the current flow in one way direction. Okay, when I just mentioned AC to DC already, so you need to change. The function now is what? Rectifier. Okay, the diode become rectifier through the process of rectification. Okay, rectification, actually we got two types. Okay, this process can produce two type of the result. First one is a halfway. Okay, halfway means you give me the full, I just output half only. Okay, I cannot give you the full output. I only give you the half. Okay, so that means half current. So you give me the full alternating current, I just give you the half direct current. Maybe first cycle can read, second cycle cannot read. This one we call half. Okay, if full rectification means I totally convert. Alternating current, okay, I all convert become direct current. Okay, means I never miss any information. This one is full rectifications. Okay, now we see how about the diode can produce full and also half rectification. Okay, this one is a one activity that from your textbook. You can refer your textbook. Okay, this one is a one of the kits. They're just like the rectification kits. That means inside they sure got semiconductor. So they join with the power supply. Okay, through the semiconductor. After that, they join with the CRO. This one CRO actually they want to display. Okay, if don't have CRO, we cannot know there's a direct current or alternating current. So that means they display the screen. Okay, remember this one is a we learned before for the chapter 4 cathode ray oscilloscope. They're just like your thermionic emission. That one, all the thing is inside there, electron gun. So from here, this one is to build a rectification circuit. Okay, this one is input. Can you see the voltage input is an alternating current because they got up and also down, up and also down. Okay, they're just using one diode. Okay, first round, we know alternating current, sure the current move in opposite direction. Okay, first round when they just start from the up. Okay, up go to D. Okay, no problem because positive is it. They go to the D, then come down to the load. So the loads must join with the CRO. Then we can read the reading. So after the load, then I can go back. So that means the first cycle, no problem. Okay, I can pass complete the circuit. So they show the first cycle, they got readings. Okay, they got voltage. Second cycle means now alternating current will change opposite direction. So they move from the diodes. When they move from the diode, they go to the load. After the load, they want to go through the diodes. Then this situation, we find it, they cannot go through because this one is a reverse bias. Remember the reverse bias? The PN junction, the center, the junction, the depletion layer become thicker. The electron cannot drift. So that means that one we call reverse bias. Reverse bias means the circuit is not complete. Circuit not complete means no reading. Okay, your CRO cannot show the reading. So you find the second cycle that is a flat. Okay, then alternating will be repeated again. So from here, you can see the third cycle up again. So this one, we call it as a halfway rectification. So you can see very clear at the CRO, they show halfway only. First cycle, okay. Second cycle is nothing. Then third, then number 4 don't have. Number 5, then continue. So this one we call halfway rectification. So that means during the reverse bias, maybe the energy will be lost lah, because you need to come down, then flat again, then up again. So that means this situation, they will make the energy loss. Okay, so this one is if I using one diode, they can produce direct current. This one is a direct current. You can see all above the graph. Okay, above the graph means there's a positive. So this one is a direct current. They always produce direct current, but not full. Okay, only half. So this one when I using one diodes. Okay, now I want to produce a full. How to use the diode? So we go and see how to go to arrange the diode. Then after that, we can using the full rectifications. Okay, this one still half. Okay, we show you. Sorry, this one is full already. Okay, full. Okay, you can see the circuit here. Rectification, the kits. You can see we got 4 diodes. We got 4 diodes. Then this one is a kits. Then the joint power supply and show with the CRO. So from here, I draw for you already. This one is called bridge rectifier. We call bridge rectifier. Yeah, correct. So that means you got 4 of the diode join become one of the bridge. Okay, this one is a diamond shape of the 4 diodes. So remember, 2 diode must be forward bias, 2 diode must be reverse bias. So that means you can check lah. Okay, D1 and D3 same pattern, forward bias. Okay, then the D2 and D4, if I from the top, this one should be reverse bias. So we can say D2 and D4 is a same pattern. Then D1 and D3 also is a same pattern. Okay. Okay. So from here, we're going to see the first one, input. Okay, input is alternating current. Okay, student, you still can see me or not? Because the line a little bit problem. Okay, still can see me or not? Hello, student. Okay, just answer me. Can okay, Khatija. So I continue. So from here, this one is input. So input, you can find there's an alternating current. Okay, when I just go in, this one bridge rectification. Okay, this one is a bridge rectifier. Through the rectification they can produce, you can see this one is the output. Okay, the output you can see every cycle we also got info. Okay, we never lost. So from here we just show this one is a full wave. Can you see the CRO? CRO they show about the full wave. Okay, the full wave of the wave pattern. So this one we call it you see wrong already. Okay, I do some changes. This one is a full one, not half already. Okay, I do some changes. This one is a full. Okay, full wave. Okay, so I show again. This one is a full wave rectifications. Okay, later I explain for you how to move, how the current go to run about the bridge rectifier. Okay, now we go through one by one. Half wave first. Okay, half wave rectification, the situation like this. Okay, we're using AC. AC, you can see the voltage. There's a up, down, and up, down. Okay, so from here, they pass through one diode only. Okay, one diode means now we're going to show. Okay, we separate by cycle, got positive cycle and also negative cycle. Okay, positive cycle means the upper part. Upper part we call positive cycle. Positive cycle, we can call it is a forward bias. Forward bias means the connection is okay one. Forward bias and allow the current to flow it. So the current how to flow? Okay, we just go to C, A to B, C, then go to the R. R is a resistant. This one R must join with the CRO because they want to see the result. Okay, they join with the CRO. So now how to movement? Now the movement is a C to D. C go to D means go downwards. Then after that, from the D, go to the E. Then this one we call complete circuit. When they just complete, okay, then they produce one of the cycle. Okay, so the cycle we follow the R. Now the direction is go down. So we assume go down is a positive. So there's a up. Okay, now we go to negative half cycle. Okay, negative half cycle means now they move in opposite direction. The bottom one is a negative. Okay, now they start from the E. Okay, go to the D, then go to the R. Now the R direction is go up, is it? Okay, go up. Until C. Okay, until C. Actually, they cannot move already. Until C cannot move already because your connection is reverse bias. You see the diode. This one is an anode. This one is a cathode, is it? Now you current go to the cathode, actually is cannot in. So from here, this one we call no current flow. Okay, you must complete the circuit, then we call current flow. If your circuit is not complete, actually the current is not flowing. Okay, so from here, you can say the current how to flow. Flow halfway only. The current flow E to D to C, then stop already. Okay, no more. So the second cycle, you can see there's a empty. There's a nothing. Okay, so this one from the AC, they convert become DC. But this one is a half wave rectifications. Okay, so from here we can say about the diode, what's the function? Diode is a convert AC to DC. You also can say now the current just can flow in one direction. Also can. Okay, it got graph to show you, actually you can show about rectification already. Okay, so this one is a positive and also negative half cycle. Okay, now you see the example. This one they show the current flow. First way, okay. Then the second way, when they just go until the positive, they stop already. So because there's a reverse bias. So this one they produce is a halfway rectifications. Okay, this one is from your textbook. Up is a positive up cycle. Then the down one is a negative half cycle. After pass the diode, okay, they can produce a positive. Okay, but the negative is nothing. No negative half cycle. Okay, they just can convert the positive cycle. Okay, because positive cycle is what? Positive cycle is a forward bias. Okay, so finish the halfway. Now we need to go to full wave lah. Okay, about the ridge rectifier. Okay, we go to full wave rectifications. Okay, you can see this one. More complicated. Okay, more complicated. Okay, so this one more complicated. You can see about the input. The input is a alternating current. Okay, so from here they need to, this one we call bridge rectifier. Okay, how the arrangement? B and D. B and D is the same pattern. A and C is the same pattern. So this one we call it bridge rectifier. Okay, so from here I want you to see the red color first. Okay, red we call first half cycle. Okay, we go to create the first half cycle first. A. Okay, we start from the red. Okay, red color, then we go through to the B. Okay, I start from the top, then I go to the B. Okay, after the B, actually I cannot go to the C. Why? Because the C is a reverse bias, I cannot go in. So that means I just can go downwards. I just can go to the downwards. That's a resistor. Okay, the resistor join with the CRO. Okay, then after that, I go after the R. Okay, from the R, I come down, is it? After that, come down, then I go. Okay, this one, you focus for this part. This part actually is overlap. They never join. The circuit is not joining. They just overlap. One up, another one is down. So they just overlap. So from here, the red color arrow, they go to the R, then they go through, go straight. Then they go to the up, then they go to the D. Okay, so that means they pass the diode B and pass the diode D. After that, go back to the Q. Okay, so I repeat, move to the B first, then go to the resistor, then go to the D and go back to the Q. So this one we call first cycle. Okay, so we go to the another cycle. We see another cycle actually can move or not. So another cycle, there should be the blue color lah. We refer the blue color. Okay, now the blue color, they start from the bottom. Q start first. Okay, Q, blue color is it? Okay, go up the bridge. Then they cannot go to the D. They only can go to the C. After the C, they must go to the resistor. Okay, how the resistor direction? They go down. Also go down. So that means I don't care your first cycle or second cycle. When the current just pass through the resistance, there's a go down. So the direction is the same. When it just go down, okay, focus for the blue color, then you up. Go, then you up. Okay, until here you cannot go to D because you cannot go back to the same direction. You must go to the opposite direction. So you must follow the A and go to the P. Okay, you start from the Q, you must end the P. You cannot start from Q, end from Q. Okay, so this one is a one complete circuit. So from here, the arrangement for the 4 diode we call as a bridge rectifier. Okay, a complete cycle of the current to flow in the same direction through the load R. Important, we want to focus is the R. Okay, if the R, the current flow in same direction, so we call it as a direct current. Okay, so we go through to the next part. Okay, we go to draw one by one. Okay, this one is two-wave direction. Two-wave. So we go to blue color first. Blue color, they're using transformer. Transformer also can be one of the power supply. Okay, so from here, first cycle is a blue color. Green color is a second half cycle. Okay, we start with number one. Number one, we start from the AC input. Okay, then they go through to the first one. First one diode, they go in. Okay, when they just go in, then this part cannot go lah because this one is a reverse bias. So they must go to the load. So number three, they go to find the load. Okay, now the direction go to load is go downwards. Okay, go downwards. Okay, after the load, they will go back. They want to go back. Okay, want to go back 5. After the 5, they must up. Okay, they must up to find the diodes. Okay, actually they cannot go up again because you start from the up, you cannot go back to the up. So you must go downwards. So to find another diodes, then come down. Come down, after that, go back to 7. So the whole step is a 7 step from starting until ending. So this one we call first half cycle. So no problem. First half cycle, that means you can create. So you can draw the graph up. Okay, now I go to second half cycle. Means I start with opposite direction. Okay, just now we start at the top, is it? Now I start from the bottom. Okay, bottom, green color. Okay, I must up. I must up. So I go where? I go to the bridge first. Okay, in, then I go to the another diodes. I up. So until this part, I cannot go to the diode for the number 2. Okay, I need to go to the resistor because you cannot reverse bias. So they continue. Then they continue. Can you see the current pass through the load is the same direction? So don't care first or second. When they pass through the resistor, it's the same direction. So that means when they join with CRO, they will show you the direction of the current now is a direct current because there's a one direction only. Okay, after that, continue. Okay, there we go. Okay, until this part. Until the point number 6. Okay, they never come back one. They cannot go downward. Go downward means go back to the original place. They must go another side. So they're up. Okay, after that, go back. Okay, so the green color is the second cycle, also complete. So that means first and half, no problem. So that means all is a forward bias. So they can produce a full wave rectifications. Okay, so this one is a positive half cycle. So we start from the positive at the top first. So you can see the explanation. Diode D1, D2. Okay, now D1, D2 is a forward bias. Okay, D3 and D4 is a reverse. So we never go through D3 and D4 because I want forward only. So from here, they're starting from the D1. Then go to the R. Then go up again. Then they go to D2 and go back. So therefore, D1, D2 allow the current flow, while the D4 and D3 and D4, they prevent the current flow. So for the first positive half cycle, we reject D4 and D3. We only using D1 and D2. Okay. So the second one sure is a negative half cycle. Negative half cycle means I reverse the diodes. Now D1, D2, I block. Okay, why? Because D3, D4 now is forward. D1, D2 already is a reverse. So I just block these two diodes I don't want to use. So I start at the bottom. I go up. Okay, I straightforward go to D3. Then go to the resistor again. Then come back, go up again, go to D4. Then go back. Okay, so this one is how to produce another cycle. Then after that, this one is a negative cycle, but you push up already. Okay, when you draw the graph, all the cycle already is up. Okay, because when they pass through the R, it's the same direction. Refer to the R, we never refer to the input, we refer to the output. Okay, so from here, every time just pass through the diode, sure produce alternating current, convert to direct current. Okay, so you want to produce is full wave or half wave is depend for your diode arrangement. Okay, one diode produce half wave. 4 diode arrangement bridge rectifier, you produce full wave rectifications. Okay, full wave rectification, there's a process where the both half every cycle of the alternating current is made to flow in same direction. So that means you can say you convert. This one is an alternating, convert become direct current. Okay, so you can see the graph, there's a difference. All above means the direction is the same already. Okay, now we see the 3 sample. This one we call alternating current. This one is a direct current after you convert. Okay, this one is an example for the steady direct current. This one is steady. That means they do not lose any energy. They're just constant, never changes. So this one is also direct, but this one is steady. Okay, so we need to introduce another component. They call capacitor. Okay, this one is an example for the capacitor. Okay, first one, you're going to see the capacitor actually what's the function. When the current pass through the resistor and also the capacitor is charged and store energy. So that means the capacitor is simpan charge. They keep the charge, okay, store the energy. So when there's a no current pass through the resistor and capacitor, then the capacitor can be discharged. So that means I keep the charge. Later you don't have charge already, then I provide the charge. So this one is a function for the capacitor. So important when we using capacitor, when reverse bias. This one is a good. Reverse bias already know voltage, is it? But now the capacitor, they got store the charge, is it? So now can release the charge. So that means they still can provide it, but less lah. The charge they still can provide, but less a bit. Okay, so the energy from it is used produce the voltage across the resistor. As a result, they can make the output direct current become smooth. Okay, just now we find the second cycle is nothing, is it? There's an empty, is it? But when you put the capacitor, they can make it become smooth. So although there's a reverse bias, but they still can produce a little bit charge. Okay, so this one we call capacitor. Actual function capacitor, there's a smooth the current in the rectification circuit. Make it become smooth. Okay, when it just becomes smooth, the graph drawing is a different. Now we see the graph, what's the difference? Okay, smoothing the halfway rectification output. Okay, this one is a capacitor. Capacitor must join parallel with the resistor. Okay, the symbol is double line, same. You don't draw one shorter, one longer. That one is a battery. Okay, when you draw the capacitor, the symbol, they're just like the equal sign. Okay, but longer a bit lah. So this one we call capacitor. Okay, when I just put the capacitor parallel with the resistor, okay, we see what happened. Okay, you see the graph. This one is a graph output. First cycle, second cycle actually is empty, is it? Then you complete with the third cycle. So the first one, they say capacitor is charging. When you provide the voltage, capacitor charge. When this part, when your voltage is dropping no more already, then you go to reverse bias. Now the capacitor release the charge to make the whole circuit more smooth. Okay, they do not straightforward become zero. Okay, so that means when you draw the graph until this part, you draw sliding. You draw the line is sliding, means here they still got potential different. They still got voltage across the R. Then after that, go to until the end, then they go back forward bias. So that means they can help the whole process become smooth. The voltage can flow become smooth. They never straightforward drop become zero. So this one is a function for the capacitor in the rectification process. So you can see this one is a diagram, alternating, pass through one of the diode, they got capacitor. So when you just draw, then you can draw the sliding line. Okay, the down one is a dotted one, that one is the original. So I draw the slide, then I up again, then you continue to draw it. So when you see the graph like this, meaning is inside the circuit they sure got capacitor. Okay, so the capacitor important function is move thing. Okay, make the whole circuit become smooth. Okay, now we go and see the full wave. Full wave also can put the capacitor. Okay, now you see full wave. Okay, full wave rectification, I also put the capacitor. Although full wave is an old cycle also got, but there's still got a little way that will lost the energy. Okay, we go and see. Okay, this is a capacitor. Okay, see the graph. The graph, although there's a full wave, okay, when during this part, the capacitor is charged. So when you see the graph, when it just up, the voltage is up, then they will drop, is it? Drop, then to make another cycle. During this area, the potential difference will be dropping. Dropping a bit, then up again, is it? So the capacitor, they are start to release. Okay, they are start to release. So that means this one full wave rectification, if I put the capacitor, the whole process will be very smooth. Okay, because a little bit way they go to drop, they also go to avoid. They prevent. They make the whole system become flat. Okay, they don't want go down and up, down and up. They want to make it become steady, just like the steady current. Okay, so from here you can see this one is alternating. When they pass through the bridge rectifier, they produce the full wave rectification. So when I put the capacitor, when you draw, you must draw just like the wave pattern. There's like sliding only. Okay, so like this, they do not lose any energy. Okay, they can save the energy. After that, they can produce the steady current. Okay, so this one is a function for capacitor. So now we can do some, okay, you can see the diagram here. Okay, this is the voltage, is it? So the capacitor is charging. So until this part, okay, when the voltage you want to drop again, then build again. So this part, the capacitor discharge. Okay, they keep the charge, then they discharge. Okay, until you want to up again. So now the capacitor charge again, then they discharge. So that means the capacitor function must be charge and discharge, charge and discharge. Okay, if you never let the capacitor to discharge and charge, actually capacitor is not function. Important, they want charge already, they need to discharge. Okay, so that means the capacitor can be functions. Okay, now we go through more detail about the capacitor. Capacitor is the connected in parallel with the R. This one is a key word you need to know. Okay, when you see the capacitor join series, actually cannot function. They must parallel. Number two, when the power supply just turn on, okay, the output current becomes smooth. Now you can see smooth. Okay, just like sliding a little bit. When the potential difference increase, the capacity will be charged and the energy will be stored in the capacitor. When the potential difference just decreases, when it just drop, the capacitor will be discharged so that the output current does not fall until zero. Okay, the energy stored in the capacitor will be maintain the potential difference across the resistor. If you never put the capacitor, later when the voltage just drop, that means don't have current pass through resistor. So the drop becomes zero, then you up again. So that means you waste the energy. Okay, so from here, the smooth output waveform show that the capacitor function is what? That is the current smoother. Current smoother. Make the whole circuit, the current becomes smooth. Okay, so from here, they got one of the question you ask. If I using direct current, is it the capacitor can function or not? Okay, anybody here can answer me? If I using direct current, okay, the capacitor can function or not? Okay, we're going to wait the student to answer. If I'm using direct current, okay, capacitor can function or not? Okay, so anyone here can answer me? So we just wait because the line today got a little bit problem. Okay, cannot smooth. Okay, anybody? If I'm using DC, the capacitor can function or not? Okay, how many is on the line? You can answer me. Okay, I don't want using AC. I'm using DC. Then I put the capacitor here. Capacitor can function or cannot functions. Okay, anybody can answer me this question? Nobody. Or the line too slow already, cannot show. Okay, who's on the line can answer the question? Yiru can answer or not? If I'm using DC, capacitor can function or not? Okay, so the student, I don't know, is it the line problem or what? Okay, still no people to answer me. So I just go to explain. Actually, cannot. Yeah, Mei Ling to told me there's a cannot. Sure cannot. Okay, Ling Han also say cannot. Yeah, there's a memang cannot. Why? Because you see the direct current. Direct current always in one direction. One direction, actually, you just let the capacitor to charge. That cannot recharge what? Only charge. So that means if you're using the alternating current means first round you let it to charge. Second round you are opposite direction. That means now the capacitor can be release the charge. Okay, third round the charge back, then release the charge. So that means this one we call it is an alternating current only can be function for the capacitor. If you're using direct current, actually is cannot. Okay, so the answer is cannot. Okay, capacitor only can be functioned in alternating current. So some of the characteristics you need to know lah. Capacitor function, store the charge. Okay, release the charge. Number two, they become current smoother in the rectifications. Then after that, the connection must be parallel with the resistor and the capacitor only function in alternating current. Okay, so this one is a capacitor. Okay, so our lesson actually today is earlier a bit. So we just until here, then complete the semiconductor diodes. So what you need to do, there's a practice 5.2. Okay, I think this one you do already. Actually, you can check the answer. The answer from your textbook actually got. Okay, number two, you need to do the Google Classroom there. I already put out some of the exercise about the bridge rectifier you need to complete. After that, turn in. Okay, this one's another PVD for 5.2. Okay, so today lesson actually just until here. One more is your Google form. Okay, your Google form you need to key in for today attendance. Okay, they got code lah. Somebody help me to type the code. The code for today is a semiconductor capital letter. Okay, semiconductor capital letter. Okay, no spacing, only the word. Okay, semiconductor. Okay, semiconductor. After that, no spacing. This one is a today code, semiconductor. Okay, so from here, our lesson until here only. So the student can be do the work around 30 minutes lah, let you to do the works. Okay, so just thank you. Yeah, Ling Han, that's correct. Okay, just thank you for everyone to attend the class. So today 5.2 we finished already. So you doing the work, please, and also upload. Last time you not yet finished the exercise, please turn in. You can check in the Google Classroom. If you not yet turn in, actually it's there already. So better you go to turn in. because that one is your PBD marks. Okay, thank you, No Queen. Okay, everybody, just thank you for your attend the class. Okay, bye everyone. See you the next lesson.